In this video, we will continue our review of transformations. I'm talking about rotations, reflections, dilations, and translations. In the previous video, problems 1 through 7, we kept it very basic. We reflected over the x and the y-axis, and we rotated around the origin. In this video, we're going to get a little bit more advanced. We're going to reflect over other lines other than the x and y-axis, and we're going to rotate around other points rather than the origin. In the previous video, I mentioned that you need to memorize these rules. So if you have not memorized these rules, you need to pause the video and memorize them now. I added in these lines right here to emphasize the fact that between these lines, these all take the point x comma y, and they all reverse the x and the y. So it's some kind of y and x, and so all you have to worry about is how the signs go. And outside the lines, it's just x, y in the normal order. Anyway, pause the video and make sure that you can write down this list from memory on a sheet of scratch paper before you continue. Okay, so problem number 8. I'm really not going to use a rule or anything for number 8. Reflecting across the line y equals 1, I just have to know that y equals 1 is a horizontal line. Okay, so here is the line y equals 1 right here. So just instead of, for example, reflecting across the x-axis, I'm going to use this as my mirror. Okay, so for example, the point L is 1 above this line, so I'm going to go 1 below that line, and that will be L prime. K is 1 above, so I'm going to go 1 below, so that's going to be K prime. Alright, and then the point J is 4 above the line, so I'm going to go 4 below the line. Alright, so this will be point J prime. Alright, then I'll just connect these dots, and that'll be it. So that's really it for number 8. That's the quickest way. For number 9, we need to rotate this figure 180 degrees around the point -1, 3, which is not the origin, which is a shame in a way because we have this nice rule that we can use. If we are rotating around the origin, we can use the rule opposite of x, opposite of y. So I've decided that the quickest way to do a problem when you have the graph given is just to pretend. Pretend that the point -1, 3 is the origin. Okay, let me show you what I mean. So here's the point -1, 3. So -1, 3 is right here. Alright, let's pretend this is the origin. So I'm going to draw a fake coordinate system on here. Okay, and then for the rest of this problem, I'm just going to pretend this is the origin so that I can do the rules. Okay, so looking at the 3 points that I have, let's see, J, K, L. So the point J, I'm using my fake set of axes. The point J has the coordinates -3, 2. Okay, and the point K has the coordinates 0, -1. and the point L has the coordinates -3, -1. Now those aren't the true coordinates, but those are the coordinates relative to, if I pretend that this is 0, 0. So pretending that this is 0, 0, I can go ahead and use the rule. Alright, so the rule says 180-degree rotation, I do opposite of x and the opposite of y. Okay, so that would make J prime be, so the opposite of x, that would be 3, and the opposite of y would be -2. Okay, and then K prime, opposite of 0 is still 0, and the opposite of -1 is +1. And then for L prime, the opposite of -3 is +3, and the opposite of -1 is +1. So just be careful, because I'm going to now graph these points still using my fake x and y axis. So the point 3, -2 using my fake axis would be, alright, 3, -2 would be right here. Okay, and then 0, 1 would be right here. And then 3, 1 would be right here. So this was J prime, and this was K prime, and this was L prime. And now I'm just going to connect those dots. And that's it. Now be careful, because these coordinates are not actually the coordinates of, these are not the real original coordinates, and these are not the real coordinates of J prime, K prime, and L prime. So if they ever ask you to list the actual coordinates, you could, and these would not be they. So if I wanted to list the true coordinates of the pre-image and then the image, I would have to do something like this. So my graph is correct, but now I'd have to say, well, point J is actually the point -4, what was that, 5? Yeah, -4, 5. Okay, and J prime is actually 2, 1. And the point K is actually -1, 2. And K prime is actually -1, 4. And point L is actually -4, 2. And L prime is actually 2, 4. Alright, so if they ask you to list the coordinates of the pre-image and the image, you have to, in the end, go back to the true x and y axis. But this using the fake axis is the quickest way to do the graph. And sometimes that's all they're really asking you to do. So number 10, we have to dilate from the point 2, 5 by a scale factor of 4/3. So again, I think a useful technique would be to pretend that this point is the origin. Because then all I have to do is multiply everything by 4/3. Maybe I should go back and look at an example that we did in the previous video. When we wanted back on problem number 7, when we dilated from the origin by a scale factor of 3 over 2, all we had to do was multiply x and y by 3 over 2. Alright, and then you just get the answer. Okay, but because this is not from the origin, it is from 2 comma 5, I cannot just multiply everything by 4 over 3. That would be a common mistake. But if I pretend, so the point 2 comma 5 is right here. So 2 comma 5 is right here. So I'm going to pretend that this is the origin, so I can do what I did the last time. So if I pretend this is the origin, then this would be my fake x-axis, and this would be my fake y-axis. Okay, so now let's write our fake coordinates. And maybe I'll just write the word fake above this. Everything I'm about to write right now, it's all fake. The graph will be accurate, but the numbers are not actually accurate. Okay, so let's go ahead and write down our fake point J. Alright, using the blue lines as my x and y axis, my fake axis, point J is going to be, let's see, -2, 4, -6, comma 0. So that's -6, comma 0. What about point K? Fake K. This would be -3, comma -3. Alright, obviously those are not the actual coordinates of point K, but they are the fake coordinates of point K. And then L. So let's see, that's going to be -6, comma -3. Alright, those are the fake coordinates of point L. Alright, so using my fake coordinates and my fake axes, since I'm pretending this is the origin, I should be able to use simply multiply everything by the scale factor. So what I'm about to do now is I'm going to take, for example, I'm going to do 4 over 3 times -6, and I'm going to do 4 over 3 times 0. Right? I'm just going to do that to everything. And if you do all that multiplication, these purple points are what you get for your fake images. Just as one quick example, look at how I got -8. I have 4 over 3 times -6. You could think of this as -6 over 1. So this would make -24 over 3. Well, 24 divided by 3 is 8, so that's how I got -8. Anyway, I'm going to plot these points now. Again, be careful to keep using your fake axis. So -8, comma 0 would be, let's see, counting from here, that'd be -2, 4, 6, 8. It would be right there. Alright, so this is going to be J prime, and that point is actually accurate. K prime, -4, comma -4. Again, using the fake axis. -4, -4 would be right here. Okay, so that is going to be my K prime. And then -8, -4 is going to be right here. And that will be my L prime. And then you just connect the dots. Okay, and I think I would prefer this to be red. And that's it. That's how you do number 10. Alright, now number 11 involves a combination of transformations. First we're going to rotate 90 degrees clockwise around the origin, which is great because we can use the rule. And then we will take that image and reflect across the x-axis. In both cases we can use rules that we have memorized. So 90 degrees clockwise around the origin, we have memorized that that rule is y opposite of x. So let's just remember that. Alright, I'm just going to put y opposite of x to kind of remind us, because that's what we're going to do right now. So I'm going to have j prime is going to be y, which is 5, and then the opposite of x, which is 4. And then k prime, y is 2, the opposite of x is 1. Notice how I'm saying opposite of x when I read this rule. If I say negative x, I'm going to be tempted to put a negative sign right here. That's a common mistake. X is already negative, so I need to do the opposite of that and put positive. So I encourage you to read these rules. When you see a negative sign, say the opposite of x or the opposite of y. Anyway, L prime, we're supposed to do y opposite of x. So y is 2, and the opposite of x would be 4. Okay. Okay, you are only required to draw the last one. Alright, I'm not going to draw the image in between because I don't have to. So we're supposed to take this image and now we are supposed to reflect it across the x-axis. So we've memorized that rule too. That's x opposite of y. Okay, so x opposite of y. So that's what I'm going to do right now. Let me give myself a little space. So j double prime. Okay, x and then the opposite of y. So that's going to be 5 and then negative 4. K double prime. X and then the opposite of y. L double prime. X and then the opposite of y. Alright, and that's what we are supposed to actually graph. So let's see, 5 comma negative 4. Okay, 2 comma negative 1. And then 2 comma negative 4. Alright, so this was j double prime, k double prime, l double prime. And then now I will just connect all those dots. And there you go. Okay, for number 12 and 13, we're supposed to describe in words the transformation that maps triangle ABC onto A prime, B prime, C prime. We need to fully describe the transformation, stating the center of rotation, etc. Well, looking at number 12, you need to ask yourself, does this look like a translation? Meaning you just slid the triangle across the page. Does it look like a reflection? You know, is it backwards? Or does it look like a rotation? And at a glance, I'm hoping you can see that this is a rotation of some kind. You can see that the order of the letters did not change. You know, we have C, we have A, B, C kind of going clockwise. And here I have A prime, B prime, and I guess that would be C prime, going like this. So it's not backwards, it's just rotated. So it looks like the point C did not move. That makes it the center of rotation. So it's rotating. This would be clockwise around the point C. So the only question is how far, how many degrees? Well, look at CB and then look at CB prime. Alright, what kind of angle do you see between one and the other? Alright, hopefully you can tell that is a 90-degree angle. So that's how you know this is a 90-degree rotation. So this is 90 degrees clockwise rotation around C. And I'll just go ahead and say 2, 3 just to be thorough. Okay, let's just slide over and look at number 13. Now this is clearly a dilation. I see the small triangle ABC is right here, and it's expanded. Alright, it's grown to be A prime, B prime, C prime. So that's clearly a dilation. And A is clearly the center of dilation because that's the one point that didn't move, and everything is stretching out from there. So I know that A is the center. So all that I need to know is what is the scale factor. So the scale factor, which I always call K, is new. It's a new length divided by an old length. Alright? Well, I put the word length by accident. Scale factor is all about new over old. And yes, they are lengths. So the easiest length to use is the one that is horizontal. The diagonal ones are tough. But look at CB and look at C prime, B prime. And so look, we need to do new over old. The one with the primes, that's always going to be new. So how big is C prime, B prime? Let's see, 2, 4, 6. So that's the new. And how big is it? The original. Well, that's 2. So that means that the scale factor is 3. Okay, so this is a dilation from point A, which is the point 5, 5, with a scale factor, whoa, of 3. Okay, for number 14, I'm supposed to fill in these blanks. I got this rectangle, and I want to describe the transformations that would map the rectangle onto itself. When you talk about mapping something onto itself, you really are talking about lines of symmetry. So the line y equals what would be a line of symmetry. Okay, remember that y equals is a horizontal line. So what is a horizontal line that would be a line of symmetry? That's all we're really asking. Okay, so let's see. This is alright, it seems to be 6 units tall. Alright, so if I put a line right here, this is going to be splitting this thing down the middle. Okay? Yeah, that's a line of symmetry. So a reflection over this line would map the rectangle onto itself. So this is the line y equals -1 because of the way it's down 1. Okay. Now, the line x equals what? Well, x equals something is a vertical line. So they're simply asking me now for the vertical line of symmetry. So, I'm just going to move this. Alright, the vertical line of symmetry is right here. See how this line splits the rectangle down the middle? Alright, so this line of symmetry will map the rectangle onto itself. If you reflected over this line, the rectangle would still look the same. This is the line x equals 3 because it's over 3 from the y-axis. So x equals 3. Okay, what if we do rotation? Okay, and a rotation around what point? So let's start by asking ourselves, what's the point? What's the point? What's the center of rotation? Well, that would be the center of the rectangle. Maybe I am going to need both of these lines back after all. Remember this line, y equals -1? If I have both of these lines showing at once, it really helps me see that the center of the rectangle is right here. This is the point 3, -1. So that is the point around which we will rotate. Alright, 3, -1. It's the center of the rectangle. Now, if I rotated 90 degrees, I'd be turning the rectangle sideways. It would not look the same anymore. It'd be like that. So, the only way the rectangle is going to look the same again is if I turn it upside down. And of course that would be 180 degrees. If I just flip it upside down, it'll be a rectangle, it'll be a vertical rectangle again. So we're talking about 180 degrees. Okay, so that's it for number 14. Alright, number 15. Draw the result of the following transformations. Reflect triangle ABC across the x-axis, then translate A prime, B prime, C prime up 2 units. You're only required to draw the final image. Okay, so reflect across the x-axis and then move it up 2 units. Okay, reflecting across the x-axis is so simple that I think I will just use common sense for this one. So if I reflect across the x-axis, so look at point A. This is, let's see, 2, 4. This is 4 units above the x-axis. So I'm going to go 4 units below the x-axis. So this will be A prime. Okay, and then B prime would be here, and C prime would be here. Alright, so A prime, B prime, C prime. Alright, maybe I'll go ahead and connect those. Okay, so I reflected over the x-axis. Then we need to translate up 2 units. So that's very simple. Okay, so if I translate up 2 units, then that would put C double prime actually back where it started from. Alright, but that is C double prime. If I move point B up 2 units, well, B prime at this point, that's going to put it here, so that's B double prime. And if I move point A prime up 2 units, That's going to be right here, and that'll be A double prime. Okay, let me go ahead and draw that. Okay, so there I've drawn it. Now the last question is, describe a single transformation that maps ABC onto A double prime, B double prime, C double prime. Okay, so what would be a single transformation that would map the original black triangle onto the red triangle? So again, is this a rotation, a reflection, or translation? Well, let's see. It's definitely not a translation, because simply sliding this around, well, there's no way to match them up. Is it a rotation? Well, let's see. If this were a rotation, then point C would be the center. All right. Can I imagine swinging this thing around? Well, no, because here's B and then here's B prime. Okay, but point A is like way down here. All right, it's out of order. So this would be a reflection. All right, see how it's backwards? And if you look closely, if you visualize this line as the line of reflection, then you can see why point C is not moving, and then A is on the opposite side of that line, and B double prime are on opposite sides of the line. What is this line? Well, horizontal lines are y equals something. So this is the line y equals 1. So this would be a reflection over the line y equals 1. So we'll just write that down. Reflection over y equals 1. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.